In this video, I'll talk about how chemists measure atomic masses of atoms, the concept of relative atomic mass and relative molecular mass. Relative atomic mass. Atoms are very small and so are their masses. Then how do chemists measure masses of atoms? Masses of atoms are measured relative to each other. For this purpose, carbon-12 is chosen as a reference and is assigned a mass of exactly 12 units. Carbon has many isotopes, carbon-12, carbon-13, carbon-14. Of all the isotopes, carbon-12 is chosen as a reference for the reasons that it is the most stable and abundant isotope of carbon. Its mass can be accurately measured. According to definition, relative atomic mass is weighted average mass of an atom. Weighted average mass, as it takes into account all isotopes and their relative abundance, is compared to 1 by 12 of the mass of one carbon-12 atom. What does this mean? This means one carbon-12 atom is divided in 12 equal parts and one part is taken and masses of all atoms are compared against it. This 1 by 12 part has a mass of 1 AMU. So we compare mass of an atom against 1 AMU or 1 by 12 mass of one carbon atom. Let's understand this by taking an example of oxygen atom. An atom of oxygen weighs 16 times more than 1 AMU or 1 by 12 mass of one carbon-12 atom. So relative atomic mass of oxygen is 16. As it is a relative scale, relative atomic mass has no units. For finding mass of an atom of an element, we have to multiply relative atomic mass with 1 by 12 mass of one atom of carbon-12. So mass of an atom of oxygen is 16 times 1 by 12 times 12 AMU, which comes out to be 16 AMU. So mass of an oxygen atom is 16 AMU and its relative atomic mass is 16. Let's see the difference between mass number and the relative atomic mass of an element. Mass number is the total number of protons and neutrons present in the nucleus of an atom. It's always a whole number. Whereas relative atomic mass is an average of mass numbers of all isotopic atoms calculated using their abundance. Let's see an example of chlorine. Chlorine has two isotopes, chlorine 35 and chlorine 37. 35 is the number of protons and neutrons in this isotope of chlorine. So this is its mass number and this is also its relative atomic mass. For the other isotope of chlorine, which is chlorine 37, 37 is the mass number and it is also the relative atomic mass of this isotope. For calculating relative atomic mass of element chlorine, we need to know their relative abundance first. Chlorine 35 has an abundance of 75% and chlorine 37 has an abundance of 25%. So we multiply mass number of each isotope with its abundance, add them up and divide by total abundance. So 35 times 75 plus 37 times 25 divided by the total abundance, which is 100%. Now this gives us 35.5. So relative atomic mass of chlorine is 35.5. Relative molecular mass. It is mass of a molecule relative to 1 by 12 mass of an atom of carbon-12. Let's take an example of water. Water is 18 times heavier than 1 by 12 of mass of an atom of carbon-12. So relative molecular mass of water is 18. How do we calculate it? It is calculated by adding relative atomic masses of all elements in a molecule. Let's calculate relative molecular mass of carbon dioxide. Now from periodic table we can see relative atomic mass of carbon is 12 and that of oxygen is 16. So relative atomic mass of carbon, which is 12, plus there are two atoms of oxygen, so 2 times relative atomic mass of oxygen, which is 16. So 12 plus 2 into 16, which gives 44. So relative molecular mass of carbon dioxide is 44. Since it is relative, so it has no units. We can also calculate relative molecular mass of ammonia. From periodic table again we see nitrogen has an atomic mass, relative atomic mass of 14. So 14 plus 3 times 1, as relative atomic mass of hydrogen is 1. So this gives 17. So ammonia has a relative molecular mass of 17.